Bismillah, as-salatu was-salamu ala rasulillah. Assalamu alaikum wa rahmatullahi wa barakatuh. I'm going to be going through chapter 1H, questions 3, 5, and 6, inshallah. Right, so we have question 3 in front of us. The question is asking us to find a rule for A. Okay, a rule for A, which is area. Now, if A represents, the letter A represents the area of this whole composite shape, what we're going to do is to split this area up into two different areas. So I'm going to call this first area, I'm going to highlight in yellow. So this yellow one is my area for 1. I'm going to call this 1. Okay. And my other smallish rectangle in the corner here, I'm going to call this area number 2. Okay. So my final rule should look like A equals to, which I want to find, A equals to area 1. Okay, so area 1 plus area 2. And this should give me the area for the whole enclosure. And please read this last statement over here that says in terms of x. Okay, and that is important for us to note. All right, so let's start finding out the area for area 1, which is the yellow highlighted section. Okay, so area 1. Area 1 is the length of this, which is the vertical. I'm calling that the length. The vertical height of this is x, and the horizontal is a 20-meter length. So my area is length times the width, so that's just going to be 20 times x. So that's just 20x. Okay. Now let's go to area 2. Now for area 2, if you look at this little shape, which is the blue highlighted section here, the length of that is part of y, but it's not exactly y, because y covers everything from the left corner of this shape to the right corner of the shape. All we want is from the right corner up till here, up till this point. Okay, this point there. Now if you notice, up till this point from the left hand corner is about 20, okay, which is the same as the one underneath. Okay, so that is 20. That means the one at the top is also 20 up till there. And if the whole length at the top is y, and this little piece is 20, how much is this little piece that we're after? And I am sure you would have figured it out. It is y minus 20. Okay, so it is y minus 20. So my area, the length, I'm gonna call this, so this horizontal of the shape of mine over here, this horizontal is y minus 20. Okay, I'm gonna write that down. Now for the other dimension, just this little part over here, just this little part over here is part of x. If you look here on this left hand side, this whole thing from the top to bottom is x. And if you compare this little green part that I've just highlighted to this, this is part of the x, okay, but not x entirely. So if you add this unknown side, the green one, with the 12, you have equals to x. So x minus 12, okay, x is the whole thing from the bottom. So if I was to have, let's say, the shape continuing on up till here, this whole thing is x. So x minus 12 should give me what I'm after. So that, just that one. Okay, so x minus 12. And that gives me x minus 12. Okay, now that is my area number 2. Now if you remember or read the question carefully enough, you will see that we need to find the rule for the area in terms of x only. So the problem occurs here when we have this y. Okay, now we need to make this y in terms of x, so that then we can input this into the formula and into our area equation and have the final answer ready. So for that, we are given some information about the perimeter of the shape. Perimeter, remember, is the outer boundary of any shape. So perimeter for this shape is equals to, so I'm going to start from the top, that's y. I'm going to go to the left, which is the x, y plus x. Then I'll have 20 plus 12. Now, this little piece over here, which I've just highlighted in the red, okay, do you see here, just above the 12, which is perpendicular to the 12, that one, that is the same as the area, the length that we found at the top, which was y minus 20. Okay, so I'm going to put that in brackets, y minus 20, plus our green part, which was x minus 20, which we've already figured out in our area bit. Okay, now let's simplify this. Now remember, the perimeter is already given, so we're going to put that information about the perimeter in the perimeter equation. So 160 equals to y plus x plus 32. Now I'll just expand the brackets. Now the expansion for this is simple because there is no number outside the bracket. It's just a plus, basically plus 1. So if you multiply 1 with the brackets, it will just open up the brackets as you see them inside. Okay, so it's going to become plus y minus 20 plus x minus 12. Now if you simplify this further, you will see that you get 2y plus 2x plus 32 minus 32. And the whole thing is equals to 160. Now 32's go away, of course, they become a 0. I'll move down a little. And eventually, if you work this out and you make y the subject, you will get your y as 80 minus x. Okay, that is my y value. Now remember, this is not my final answer. Okay, it's just my y in terms of x. Let's go back to the question. What does the question say? Read the question again, remind ourselves. Find the rule for the area. Y is not the rule for the area. So what is the rule for the area? The rule for the area is right here. We've written them down. That was the first step that we did. Area 1 plus area 2. Okay, let me rewrite that underneath. Well, let me go to the side. So we'll lose focus of our diagram. Okay, so area 1. Remember, so A in terms of x is area 1 was 20x. Then area 2, which I'm going to write underneath, is going to be, because y is 80 minus x, as we've just found. So I sub in that 80 minus x into the y. Then I will get 80 minus x minus 20. That whole thing times x minus 12. Okay. Now this task over here, this is when I turn to my CAS and do some calculations with it. Okay, so I'm going to add a calculator to my screen, and rather than me trying to expand the brackets and take so much time for this, I'm just going to get my CAS to do that for me. Alright, so I can simplify this myself. 80 minus x minus 20 is just going to be 60 minus 20. So I'm going to write 60 minus x. That's one bracket closed. The other bracket before that, please don't forget to put the multiply sign. Sometimes the CAS plays up. And there we go. That is our area equation. A of x is equals to minus x squared plus 92x minus 720. And that is your part A of the question answered. Okay, let me take you back to the question. Now state a suitable domain for the function. Now this is important to understand. If you don't understand what the domain means or what it signifies or how then you would not know how to find it. A domain for area, think about area, okay, because they are application-based problems, so you'll have to come up with a suitable domain for this. A suitable domain for this would be, remember when you put in the value of x, which is your dimensions, can the value of x ever be a negative value? I'm pretty sure you would have said no to that. Okay, so the answer is no. Yes, so your value of x, which is a measurement, a dimension of your of your enclosure, of some land, of some place, you can't have it as a negative value. Okay, so it is a given that it will be from 0 and above, right? But again, for this particular function, what would it be exactly? So we don't want any values which is going to give us a negative area, because the area, again, it doesn't make sense if you're going to get an area which is negative. All right, so we want to find out the zeros for this function. So this particular function here, next step, I'm going to define this function quickly so I can do some other steps with this. So f of x, I'm going to put this sign to control and this little sign over there that gives me this. Okay, so and then I'm just going to go up and copy, not exactly copy, just click enter, just copies the whole thing down, and that is my function done. Right, so what I'm going to do next is do solve. So I'll go menu 3.1, menu number 3, number 1 solve. I'm going to put f of x, my just newly defined function, equals to 0. So I'm finding zeros for it. So I'm finding the x-intercepts, and I found those values. And guess what these are? This is your domain. Okay, so the -2 times root 349 minus 23, whatever that is. If you want to check whether that domain actually makes sense or not, so let's say if this negative value was giving us a negative answer, would you include that part of your domain? No, you wouldn't. So you'll start from 0 to this answer, which we're going to assume now is a positive. But a way to check whether what these values exactly mean, what you do is you control enter, and you get the approximate value. So if you look, this value is 8.63, which is more than a 0. So basically what these values mean, so if you were to put in an x value of less than 8.63692, let's say you put 8.5, okay, into the function, your area will come out to be a negative value. Okay, how do I know this? Because this is a upside down parabola. Right, have a look at this, minus x squared, so it will have a maximum. This is a maximum parabola. All right, so the turning point is a max, and this x-intercept represents that at this value of x, the gradient is a positive, is going up. Right, and we can see that in part C when we sketch it. All right, so your domain is positive 8.63, but just write exact values from this point to that point. Now, why is it stopped at this point, 83.36? Try putting in 84, subbing it in, okay? Just sub in 84 into your x and see your area value will come out to be a negative, okay? Try it out. Don't believe my word for it. Try it out, please, okay? And see for yourself. All right, so let's go on to part C, which is sketch this graph against x. So for this, I will go back to my handycast, click on control, page, and then I go to graphs. I type in function of x. Now if you have a look, based on my standard screen, this is what I can see. Okay, and that's my first x-intercept at about 8.63 whatever. Now I know my other x-intercept is at around 83 or something, so I'm going to go to menu 4.1 and choose my negative my x-min as -1, okay, because I want to see the whole picture, and my x-max as, let's say, make it 90. Right, now this one you can choose your minimum at -1, choose the maximum at because this is going to be a huge function. As you can see, the function that we were getting had a y-intercept at -720, so it's a safe bet to just put a number in the maximum side which is double the y-intercept. So let's say we put around 1500. See if it works. Oh, there we go. So we've got a perfect picture. Okay, now we can see very clearly. Now this is the graph. So if you want to sketch it, all you do is just get the get the important points like the x-intercepts, which we already found in the previous one, and just copy it down in your exercise book. That's it. You're done with this part C. Now part D says find the maximum possible area of the enclosure. Now remember, this is an area function, so the y values of this are giving you the different areas at different x values. So if your x value is changing, let's say it changes from 8.3 or whatever it was to this value over here, the area keeps increasing. After a certain point, as your x values increase or become larger and larger, the area actually becomes smaller and smaller and smaller and smaller, and eventually becomes 0. Okay, we're going to stop over there. So what it's asking for is the maximum possible area and the corresponding x and y values. They're very generous with the words. They're actually telling you to find x and y values. The examiners would not be as generous. So the function that I've used, go to menu, analyze graph, and do maximum points, then choose the lower bound, go to the upper bound, and conveniently just spits out everything that I need. So 46 is my dimension. 46 meters is the dimension for x, at which my area will be maximum, and the maximum area is 1396 square meters. Okay, that is it for that question. Let's move on to this question, which is question number 5. Can I zoom in a little, but zoom out? Okay, a rectangle ABCD is inscribed in a circle of radius A. That means, let me draw something on this. That means this line segment that I've just drawn from O to B is A, and then from O to D is A as well. So what is D to B? Yes, you guessed it right. It is 2A, right? What if I take out this as a triangle? So this is my D, this is my B. What is my DB? It is 2A. And what is my A? A is my 90-degree angle. Okay. Now remember, to find the area of the rectangular function, which is this function, I'm going to have to assume a few values here. So I'm going to say that this A to B is my y, and A to D is my x. Okay, so I'm assuming the A to B is y, and A to D is my x. The reason why I do that, because if I do x times y, now what I want to find is the area should be x times y, isn't it? And that will give me the area of the function. So I need to find out a suitable function in terms of x and a's and stuff. All right. Now, using your knowledge of Pythagoras theorem, we can get a function for y in terms of x and a. Now remember, your final answer would have a in it because the radius is not specified, it's given as an a. Okay, so let's use Pythagoras theorem there, and that will give you, so this is the hypotenuse, the opposite to the 90 is the hypotenuse always. So 2a whole squared, remember not 2a squared, 2a whole squared equals to x squared plus y squared. So sort of you can see, if I want to make y the subject here, you will get y equals to x squared minus 4a squared, and that is my y. All I need to do after that is just sub in that y in this function, and I've got my equation or the rule for the area. So the area of the rectangle is x times y. Now y is root x squared minus 4a squared. Okay. Now the next question comes. That is the function for the area. The next question comes. What is the domain for this? Now remember, a root function. Okay. One thing that you should note about the root function: the root function cannot take a value of a negative. Okay. You might remember, a root of a 0 is a 0. Root of a negative 1 doesn't exist. It's undefined. root of any negative values. That's why the root functions always exist on the positive side of the real number domain. They don't exist on the negative side of real number domain. So one thing, how can you make that function a negative number? Oops, I just realized I've made a mistake in this step over here. Let me correct that. Okay, so rather than writing 4a squared, which was this 2a whole squared, minus x squared, I've written down x squared. In fact, I'll cut it out so you can see clearly what I'm talking about. So it should be 4a squared minus x squared. Okay, so the next line I'm going to erase and then rewrite. Apologies for that. So I'm going to make it in red so it is visible that this is where the mistake was. So 4a squared minus x squared. Okay. Now think of values of x that will make this function inside the root to be a 0. One quick way of doing that is take whatever's inside the root and make it equal to 0 and find out what that is. Okay, remember a is a constant, it is not a variable, so we're talking in terms of x over here. So if I have 4a squared minus x squared equals to 0, how can I solve this? All right, so move x squared on the other side and you will get 4a squared equals to x squared, eventually end with x equals to 2a. Okay, plus minus 2a. So the domain for this function is negative 2a to plus 2a.